Okay, sorry, everyone, if I missed a little piece, we'll get it back in a minute. So really quickly, as we head towards, as limits head towards infinity, all the other numbers just sort of cancel out, and we treat whatever's left as a number, like 2 or whatever. When we're heading to 0, we cancel out all the other degrees, and we're just dealing with the smallest degree. So the smallest degree on here match top and bottom. Everything else just becomes a 0, and I go with it from there. Same thing is true here on the next problem. I have 9 over x. Everything else just becomes a 0. There's so much smaller than that, it doesn't matter. This becomes 0, so it's gone. And the bottom becomes 0. So this is like having 9 over 0, which 1 over 0 heads towards infinity. It just means the smallest number is on the bottom. And we head that way, and over here, oops, I lied about that. Hold on, pause. Oh, I said it right. It's like everything else is gone. It's like having a 0 on the bottom of a fraction, which heads towards infinity. And over here, here's the biggest power. So all the other x's are gone. There's nothing left for an x. It's like having a 0 and 0 over something, any number, is equal to 0. If you don't like those tricks and rules, you don't have to use them, because we're going to have a rule that works for all those problems, known as L'Hopital's rule. There are 3 types of L'Hopital's rule problems. This is our last topic for today. But the main rule in L'Hopital is that if f of x, if you take the limit of something, and it's a polynomial, over a polynomial, and you put in 0, put in your number, and you get indeterminate, you get infinity over infinity, or 0 over 0, then the limit itself is equal to the limit of the derivative of the top over the derivative of the bottom. I'm going to actually, these are the 3 examples. All these aren't tested on the AP. We're going to talk which ones are in a minute. This first one is, if I come to this problem, I put in 0. I put 0 on the top, I get 0. I put in 0 on the bottom, I get 0. That's indeterminate, which means L'Hopital applies. And you can use L'Hopital as many times as you want. So now I L'Hopital this. I took the derivative of the top, derivative of the bottom. I put in 0, and I got an answer back of 3. They often flip between sines and cosines. And ones with e to the x have other parts that reduce, and they don't reduce. Let me show you what I mean by some of those. I'm going to go to this other side of the page. And I'm going to look at some of the problems we just did the last time. If we didn't know how to do them, we could just use L'Hopital's rule. I'm going to flip back for a second. Well, nice work back here, because I can see it better. If I've got 25x to the third, the limit, as x approaches infinity, of 25x to the third plus 2x over 5x to the third plus 2x squared plus 4. If I want to find the limit, just the standard technique, I'll put in the number, I'll put in the infinity and see what I get. Well, this would be equal to infinity over infinity, which is indeterminate, which means L'Hopital's rule applies for derivatives. So I can take the derivative of the top and of the bottom. So this would be 75x squared plus 2 over 3 times 5 is 25x squared plus 4x. Let's put in infinity. Again, I get infinity over infinity. It's still indeterminate, which means I'm going to apply L'Hopital a third time. So this time I get 120, 75 3 times, Cal. 75 2 times, Cal. Right, 150x. The 2 is now gone. Over 50x plus 4. Put in infinity. I get indeterminate one more time. Let's do it a third time. 150x is 150. That one. There's that. Skadoosh. Cal made a mistake before. The derivative of 5x to the third, Cal, isn't 75. It's 3 times 5 is 15. So I fix it for him. And we get that, and this simplifies down to 5. Was that longer? You betcha it was longer. I have to keep using the L'Hopital until I ran out of ways to do it. The shortcut method says when you head to infinity, you can just dump anything that's smaller and we'll end up with the same answer. But if you can't remember that, you can always use L'Hopital's rule like here. Let's try it on the one that goes to 0. Let's go to limit as x approaches 0 of, let's go 9. Let's just do one. I can't really read it. 9x squared plus 2x plus 9. I think that's it over. I'm not going to do the 6 because that would take too long. Let's go 10x to the third plus 2x plus 4. So I'm going to start with this problem right here. I put in 0, I get 0 over 0, which is indeterminate, which means I've got to apply L'Hopital, which would be 18x make that squared. There we go, it's better. Plus 4x plus 9 over 30x squared plus 4x plus 4. Now stick in 0. These are gone, and we're left with 9/4. There's one other type of problem that may show up, and oftentimes it looks like this. It'll say the limit as h approaches 0 of sine of x plus h minus sine of x over h. And you can see a lot of them end up looking like this. If I put in 0 for h, I get sine of x minus sine of x over 0, which equals 0 over 0, which is indeterminate. I'll explain why later on these problems work this way, but let's take the derivative of the top and the derivative of the bottom. So the derivative of sine of something is cosine of something. Times the derivative of the inside, which is 1, minus, and this thing is just gone. Now the question is, why is it just gone? Well, my variable isn't x, my variable is h. This is like having some constant in there. So it's just gone. Divided by the derivative of h is 1. So I get the limit as h approaches 0 is equal to cosine of x. If you don't see it now, we may see it later on. This is the definition of a derivative. And what's the derivative of sine of x? Cosine of x. That's where it comes from, but we can use L'Hopital to apply that on out. The third type of L'Hopital problem I'm going to hold off on till later review is sometimes you'll have problems that aren't in fraction form, but most of them are going to be, where they'll have an exponent up top. And what we end up doing is we ln both sides before we start taking the derivative. I'll work out more later on how that one works, but up till now I like the ones we have. We've done the basic rules. Okay, in your review book, and I'll write down problems to work on. You are going to turn to page, the limits section. Limits, it's functions, limits and continuity. There we go. So you guys are going to work on page, I'm going to write it right on here so I know where we are. Finished up to here. It's going to be page 108. It's going to be A1 through A7. You can use L'Hopital's rule on all of them. A9, it's a trick question. Give it a shot. The idea is to not use your calculator on those, even though it'd be a lot easier to use your calculator on those. And then this next part is calculator ones, page 111. Let's go with B1 through B9. Maybe a couple little things we haven't talked about in there, but that's okay. So those are your review questions for today. You have the 2 videos. We'll meet in class tomorrow and discuss all this. Good luck, everybody. Bye. I gotta hit save.